Hello and welcome to Technical Utkranti. And today we are into the 12th question of the array series in data structures and algorithms. So let's get started. Today we'll see how to count number of array inversions in an array. What is an inversion? So let's understand it with the help of an example. So if I is less than j, but element at I is greater than element of j, then it is called an inversion pair. So for example, for 3, 3 comma 1 and 3 comma 2 are inversion pairs because 3 is bigger but it is coming before the smaller elements 1 and 2. Okay. So it does not form inversion pair with 4 and 5, right? So other than that, like if you see 1, 2, 4, 5, they are all in ascending order only. So they don't form inversion pairs. So for this particular example, there are just two inversion pairs. So the first approach is very, very simple. We just iterate on every element, and for each element, we see that in this up like any element coming after this element, if it is less than the current element, then this makes an inversion pair and we increment the inversion counter by 1, and we do this exercise for every element. So let's look at the implementation. So this is the implementation. We are iterating on the array, and then in the nested loop we are iterating on the subsequent elements of the current element. And if we see that if the subsequent element is smaller than the current element, we increment the counter and we return the counter. So for example, in this particular thing, we see how many inversions pairs are there. So there are two, as we saw in the illustration in the PPT as well. But this is a O of n square implementation, which is a brute force implementation. In merge sort, we keep halving the array until the array of size 1 remains. Okay, for example, we divide it into 532 and 14. Then 532 is divided into 532. This is divided into 14. No further subdivisions are possible here, but here we can have 53214 like that. Now firstly what we do is we merge the latest division that is there. So 5 comma 3, if I merge, it becomes, so I'll come here. So in here we see 5 comma 3 becomes 3 comma 5, and 2 comes as it is. Then 3 comma 5, I mean this particular array and this array are merged, and we get 2 3 5. And similarly over here it is 1 4, and then this array and this array is merged, so we get 1 2 3 4 5. This is merge sort, and we'll see its implementation, but we will quickly see how can we use merge sort in calculating the number of array inversions. So what we'll do is each time the array on the right, any element in the array on the right goes before the left, uh, I mean elements of the left array, we increment the inversion counter. How do we increment it? So whatever number of elements that are left in the left array to be merged, at the instance when any element comes into the above array, that by that amount we have to increment the inversion counter. If it is not clear, we'll see in the code what exactly I mean. Okay, so we do this exercise. So for example, over here we put 2 at the beginning of the above array, and we see that there are two elements in the left array which are not yet put in the above array. So we increment the inversion counter by 2. So let's say now we are here, and in this case there is, I mean when we are putting the element of the right array in the bigger array, all the elements of the left array have already been merged, so inversion counter is not incremented. Okay, now in this case, what happens is, firstly, one goes over here. When one goes over here, there are three elements in the left array which are yet to be merged. So inversion counter is incremented by 3. Okay, then 2 goes, then 3 goes, and then when 4 goes, one element of the left array remains to be merged, inversion counter is incremented by 1. So what was the example? It was 5, 3, 2, 1, 4. Okay, it is different than the example that we were looking uh, previously, right? In the previous one, we are looking into 3, 1, 2, 4, 5, and here we got two inversions, but here the example is different. So how many inversions did we get? We get one inversion over here, two inversions over here, so three inversions as of now, zero inversions in this part. Then when one was moved, we got three more inversions, so that makes it total six. And then when four was merged, one inversion of five again came up. So there are total of seven inversions for this particular example. Let's first of all see the implementation. First, we calculate the middle value for the length of the array and divide the array into left and right halves. Okay, this particular calling of the merge recursive calling of the function ensures that we are subdividing the array until the length of the array comes out to be 1. So this particular check that you see here is done for the fact that keep dividing the array if the length of the array is 2 or greater. Okay, and once the length of the array is 1, then just return back and then carry out the merging part. Okay, now what is happening over here is, uh, this is purely merging. So what is happening is, k is indexing the array arr, I is indexing the left array, and j is indexing the right array. All right, so if the left array element is left less than right array element, then just merge the left array element and increment the index of the left array. But if right array element is greater than left array element, then that creates a case of inversion. So we merge the right array element into the array, increment the index of the right array element, and increment the inversion counter with the number of elements that are left in the left array to be merged, yet to be merged, right? So with that value, we are incrementing the inversion counter. And after both if else, we increment the k value, which is indexing the actual array. All right. Now, if any of the left or the right array gets exhausted, then we will find no more pairs, and no more inversion pairs, and then we just uh, fill in the remainder of the elements into the array. Okay, and yeah, and then we ultimately return the inversion counter. So this is 31245, the first example, and let's see if it works out. So we are getting 2, and the case in which we were counting 7 inversions, let's see how many inversions do we get. So here we get 7 inversions. So I hope this is clear, and yeah, so the lesson learned was merge sorting takes O of n log n time to sort the array. And in this particular question, we also saw how merge sort actually works. And yeah, that's it. Thank you. Bye bye.